Hello, let's look at section 5.1, which is about slope fields. And I hope you have printed the notes and you can follow along then as we go through these problems. This one's set up a little bit different. These are Avid note styles, kind of called focus notes. And you can see there's an essential question here. So let's walk through the essential question and kind of talk about what it is we're going to learn today. As we do slope fields, and you've done those before, what I wonder is what information can we get from this slope field? How does it help us? How does it get us some information about the main function? So, and over on the left-hand side, you can see there's some space for writing in your notes, making a comment, or writing a question if you want to phrase it as such. So, what if a differential equation has only one variable? Like we're looking at here with our first problem, dy dx equals 2x. Wonder what happens on this one. Well, what we need to do today is let's look at how to even draft these little slopes in on our picture. What I'm going to do is just kind of create a little XY chart. And I'm going to have y equals 1. And then I'm going to have x equals, I'm going to do -2, -1, 0, 1, and 2. So I'm going to cover all the x values that are being covered here. So -2, -1, 0, 1, and 2. And then what I need to do, let's see, maybe I should do 2. 2, 1, 0, -1, and 2. That way I'm covering all my x values on the chart here too. So when I put in x, and when x is -2, I would get out -2 times 2, I would get a slope of -4. And that would be the case for all x equaling -2, and it wouldn't matter so much what the y value is because there is no y variable on here. So really, let's just take -2 times x, -2 times 2, and I would get -4. And then -2 times 2, and I get -4, -4, -4. That entire column is going to be filled with -4. Then, when x is -1, I'd have 2 times -1, which would give us -2 in all these spots. Next, when x is 0, well, 2 times 0 is going to be 0. Got it. And back to x being 1, that'll give me a slope of 2, no matter what y value it is. And then when we're at +2, we'd have a +4 slope. Okay. Now I'm going to take those slopes and put them on my slope field the best I can. So when x was 0, I came out with slopes of 0. So when x is 0, I'm going to just put a horizontal dash in here to represent that 0 slope. When x was 1, we had a slope of 2. So I'm going to aim for the halfway point here as I draw my slanted line to get me a slope of 2, because that would have been up 1 over a half, which would result in a slope of 2. Now, this one will be a little tricky. We want a slope of 4, don't we? So 4, that's going to be quite steep. I want it to look steeper than my previous slope of 2, so that in relative comparison, I can tell that it did go steeper. All right, now we're at -2, so I need a -2 slope. So I'm going to be aiming for kind of that halfway point as I draw in my slope of -2. And lastly, we want the slope of -4, so this one gets quite steep. I think we got it. And that is drawing in a slope field. Now, what does it tell me? How is this useful? Well, if I try to, let's say I want to go through the point 0, 0, I can use these slope fields to help direct the curve. Maybe I was having my point, an initial point of 0, -2, and I would get that type of shape. Well, essentially what I'm getting is a family of parabolas here, quadratic equations, right? And if I were to solve my differential equation, we have done a little bit of this. If I just solve this simple differential equation, I do get x squared plus c, and I get a y equals. So it makes sense to me that this is a parabola. So that is kind of what a slope field does. It gives us information by looking at a picture of the original function. And we get that picture by following the slope fields, and it directs into what the curve of the original function looked like. All right, what if that differential equation only has one variable, as we did in this case? Well, that actually makes our work easier. The work is easier. Why is it easier? Because it was just a lot easier to create this table, wasn't it? Because we noticed that columns take on the same slope. Because the x value was the only thing that the slopes were dependent on. So when x was -2, well, the slope turned out to be -4. All right, next example. For this one, we do have two variables, so this will make it just a little bit more complicated. And we have quite a slope field to fill in again. And I'm going to do my table just a little bit differently this time, because maybe this is how you do yours. Maybe you didn't like my last one. So let's try this one. I'm going to do it when x is 0, that makes it pretty nice, doesn't it? When x is 0 and y is kind of whatever, the slope will turn out to be 0, won't it? So when x is 0, the slope is 0. So I'm going to go ahead and indicate that. What about when y is 0? Well, when y is 0, 0 times anything gives us 0. So we also get a 0 slope on the horizontal axis, don't we? Now let's play around. Let's say, what about when x is 1? When x is 1 and y is 1, I'm going to go for that point right there. I'd have 1 times 1, which would give me a slope of 1. So I'm going to indicate that slope of 1. When x is 1 and y is 2, I have 1 times 2, I get 2. So now when x was 1, I need a little bit steeper slope, a slope of 2. When x is 1 and y is -1, I would get -1 slope. And when x is 1 and y is -2, I'm going to get a -2 slope because I'm multiplying them, right? So something that didn't turn out very good. Something like that. All right, when x is, let's go over to 2. When x is 2, and I'm going to go for this point here. When x is 2 and y is 2, that'd be 2 times 2, I would get a slope of 4. Okay, a steep slope of 4. When x is 2, y is 1, I get a slope of 2. I should be kind of matching that slope. When x is 2 and y is -1, I'm going to get a -2 slope. When x is 2, y is -2, I get -4 slope. 2 -2 has a -4 slope. And I think you can see how easy this is to fill in. I'm not even going to do it on the chart now. I'm just going to talk about each of the points. -1 times 1 would be -1 slope. -1 times 2 would give me a -2 slope, a little bit steeper. -1 times -1 would give +1 slope. -1 times -2 would give +2 slope. Moving to the -2 column for x. -2 times +2 would give me a +4. I'm sorry, -4. So quite steep. This one should have been like a -2 slope, a little bit less steep. And then I've got -2 times a 1 gives me a -2 slope. A -2 times a -1 gives me a +2 slope. And a -2 times +2 gives me +4 slope. So this looks a little bit different, doesn't it? A little bit more complicated on drawing this out. Let's say we have a point at 0, 1, and we want to see what the original function would have looked like. I believe it's going to look something like that. And it really shouldn't connect with arrows because we don't know what it's doing outside of that, so I'm going to leave it there. For this one, it looks like, around this, we get the flattening. So I'm going to say, what if I come through, maybe through half there? Maybe this is my original point, and I'm coming back out of there. Something like that. When you draw them on the AP exam and you have to sketch the original function, the curved line, what you want to do is extend to the edges. Okay, but you do not want to add arrows. So what is the slope at 1, -2? Well, I could show then dy dx at 1, -2. Use good notation. This is a good time to start practicing that as we come into the AP exam. We would have a slope of -2. So at 1, -2, there was that -2 slope. All right, next one. This one, a little bit different, y minus 2x. We have two variables, so things will be changing. We won't get those nice columns like we did on that very first one. And why don't you go ahead, either set yourself up a table, or if you like the x, y columns, and get your dy dx this way. But I'd like you to try to fill in the slope field yourself and see how that works for you. I'm going to do just like -2 times 1, or -2 and a 1. So I'd have 1 minus 2 times -2 would be +4. So this would turn out with a slope of 5. At -2, +1, I'm going to have a slope of 5. Okay, so pause the video and then come back to me and see if yours agrees with mine. All right, welcome back. Here is the slope field that results. There's that 2, -1. Hey, I didn't do too bad on my slope, did I? Kind of matches up with that. But those are the slopes that you should have gotten. When I put in 1, whoops, let's get a pen going here. 1, 0, I came out with a slope of 0. At 1, -1, I had -1 slope. At 0, 0 anything, it turned out to, oh, I'm sorry, that's not true. Oh, I'm so sorry, you guys. I was on the wrong chart. You're probably wondering what I was doing. Let's back up. I'd have -1, 1, which gave me a slope of 3. I had a slope when I plugged in 0, 1. I got out 1. When I plugged in 1, 1, came out with a slope of -1. And when I put in 2, 1, I came out with a slope of -3, just to check a few. All right, now let's go through this equation down below. It says, write an equation for a tangent line. Keyword tangent line, I should be able to do that. To the curve of y equals f of x at the point 1, -2. So what things do I need for a tangent line? Well, for a tangent line, we need two things. We should have this down by now, shouldn't we? We need a point and we need a slope. Well, the point was given to us. So that's a freebie. That's kind of nice. And what about the tangent line? What are the slope? The slope I'm going to get from the derivative that was given to me. So dy dx was equal to y minus 2x. If I calculate dy dx at 1, -2, I would get -2 minus 2 times 1, and that would give me a slope of -4. Okay, I have the key ingredients to write out the tangent line. I'd have y minus the y value. That's going to become a plus, isn't it? Y minus negative 2 becomes y plus 2. And then I'd have my slope, x minus 1. And there's what they're looking for. The slope is y plus 2 equals negative 4, x minus 1. So there's quite a bit about slope fields, how to create them. They are a little bit of work to create, but we definitely have seen those on the AP exams. I would kind of welcome that as my free response question, to be honest. They're pretty easy. All right, the next type of problem that you may see on the AP exam are giving a slope field like we have here, and then it says sketch the graph of the particular solution that contains the point 0, 2. So we know that this is a point, it's an ordered pair, and we want to make sure that our graph goes through that. So I'm going to first locate 0, 2, and now I'm going to just kind of go with the flow of these slopes and what they're indicating. That would be the solution curve for part A. For part B, this one wants us to go through the point 1, negative 1. So 1, negative 1 strikes right there. And it's going to take on kind of a different look, isn't it? I'm kind of getting that out of that shape. And that's all that's to it for doing writing in the solution curve. Just be sure that you go edge to edge. I've learned this on an AP summer conference. You must go within edge to edge or borderline on all four sides if we were down on the very bottom or reaching the very top. The main thing is edge to edge. I guess they do give you kind of one dash forgiveness, but if you do not come that close, then you get 0 points. So I would just make sure you go edge to edge. Moving on, the next one says, shown below is the slope field for which differential equation? So this is multiple choice style. And how do you go about doing that? Well, I remember when we had that very first problem and it was all x's, or it was just contingent on x, I guess. We ended up with columns being the same. So if I have I should notice that the columns have the same slope, don't I? I mean, that's just in my mind, have slopes that are the same. And when I look down through this column, I do not notice that when x was, well, let's even make this easier on ourselves. When x was 1, let's try to move that over. Those slopes are definitely not the same. So I'm going to be able to eliminate this. Over in the margin, maybe even make a note to yourself. Kind of the easiest way is elimination. That wasn't even close, wasn't it? Elimination method is kind of my go-to on these multiple choice ones. I can start looking at those common things, like especially if I have just a single variable. This one I should see columns being the same as well. And since they're not, I'm going to eliminate that one. When it starts getting into x and y's, that's when it starts getting a little bit more interesting, because you've got that combination going on. I do know if I were in quadrant 1, I should have positive plus positive, right? X and Y's are positive in quadrant 1. So I should see only positive slopes. And I actually do only see positive slopes in there. So that makes me feel like this has got potential. What about quadrant 3? I'm thinking quadrant 3 where they're both negative. I'd end up with negative plus more negatives. And negative plus more negatives means my result is going to be negative. So I should see only negative slopes. And I do also see negative slopes in there. So this has really got a pretty good thing going for it. 0, 0 would be a good one to check. I should have a zero slope, but they did not indicate any slopes on that, so that wasn't helpful. What about at like 1, 1? Should see a slope of 1, and that's kind of fitting, doesn't it? Yeah, that's looking pretty good. Okay, I think C has some real potential. We already had ruled out A, we'd ruled out B. D, I could also play the quadrant thing on that one. Let's go into quadrant 2, where I have a we don't have positive x, where we have a negative x divided by a positive y for quadrant 2. I should be only seeing negative slopes. And right there, it broke the rule, didn't it? That's a positive slope. I can rule out D. So using quadrants and the signs can actually be a pretty quick method as well. All right, this one, just a y variable. So when y is 1, I should see that the slope, the natural log of 1, is 0. I should see 0 slopes. And do I see consistent 0 slopes when y is 1? I do not. So this is definitely eliminated. C's got to be the answer then. Notice single variable. This time the rows are same slope, or must be same slope. The rows will take on same slopes. Must be the case. All right. A couple little summary things down here at bottom. Sometimes eliminating answer choices is the best method. And if the differential equation has only x's involved, then expect your columns to have the same slope. That really does help, especially in multiple choice, to find those. And then if the y's are involved, only y's, the rows have same slope. And I think you know what I mean by that. What kind of summary thing could we do about our notes today? Well, one thing is we can draw solution curves. Over the curve, over the, not OW, over the slope field. This gives us the original function. Or it doesn't really give us the original function. This gives us a picture of the original function. Like on that first one we did, we could tell that it was a quadratic equation just by looking at the shape that it was a parabola. So there are differential equations out there that can't be solved analytically, meaning we can't manually hand do it. So sometimes drawing these slope fields, because we have the differential equation, we can draw the slopes, and then we can draw in the solution curve that can give us insight into what the original function looks like. Another thing is not all differential equations can be solved. So sometimes the best we can do are these slope fields. So hope you've enjoyed the lesson today. What is the homework? The homework follows, and it's a few pages long. You're going to be drawing some slope fields. You're going to be doing some multiple choice. Here there are, down at the bottom, you see 4 different graphs, and it's kind of a matching exercise, actually. I guess it's not multiple choice. It's matching, okay? And match again. You got 4 given equations. Match the slope field for that. Here, given one slope field, which is the original equation. Now, hint on this, I would draw in my solution curve and then think about these families of graphs and what their pictures look like. I think you'll be able to match that up quite quickly. Here again, I kind of draw in a slope field. That wasn't probably the best. something like that. It's still not fantastic. That's a better. And what shape does that take on? I think you'll be able to match that up pretty easily. And then 17 and 18, they give you an idea about what free response questions sometimes look like on the AP. So go ahead and do those. That'll be good practice. And just finally on the last one, you've got kind of a test prep there too. So plenty of homework. They are a little tedious, not necessarily difficult, just tedious. Have a great day.